Today you're going to be able to understand how to use definitive integral and its relationship to the area under the curve. So now basically what we're going to be dealing with is that you're going to be finding the antiderivative of a function, but only from one point to another point, which are going to be a and b, which are going to be these numbers here. A represents some point on your x-axis, and then b represents another point. And basically what you're trying to do is to find the area from that a value to that b value, and basically in between, so the shaded area right here. And when you do that, you'll find the area underneath the curve. All right, so here we go. Again, we're going to start with using your calculator. There it goes. All right. We're going to start with using your calculator to figure this out, and then we'll shift into how to do it by hand. Okay, so you will need to draw in these diagrams, write down these functions, okay? But I did provide you with a grid, so you have it there. All right, so we're going to write down the definitive integral that gives the area of the shaded region, and then we're going to evaluate it using our graphing display calculator. That's what GDC stands for. And so here's our first function. It's 2 minus, yes, the absolute value of x. And so you see our shaded region right in here, okay? And so we're going to have to write this integral, okay? So we know we have to have our integral symbol. What's going to go at the bottom? What value is going to go at the bottom? What do you think? Well, that actually crosses the -2. Yeah. So it's -2, because that's where the start of the shaded region is. And then it goes all the way to 2. So that represents your lower bound and your upper bound, okay? I'm basically trying to figure out the area from -2 to 2. And then what goes to the left of the, to the right of the integral symbol? The function. So 2 minus the absolute value of x, and of course we cannot forget our good old, the dx. So there is the definitive integral that represents the area of the shaded region. Okay? Yes? Well, in this particular case, if they ever ask you to write the function, they probably will give you the graph. Okay? Any other time, they'll probably already give you this integral. Okay? So the only reason why we had to write it was because we were only given the graph.
Is the indefinite integral that produces the area all the way down?
The indefinite integral is just the integration of this. It doesn't tell us the area or anything out of that. All right. So we got to pull out our calculator. So it's off. To find this using your graphing calculator, you have to press the math button. And if you notice, in my calculator, it's option 9, it's FNINT. Is it option 9 on y'all? Okay, so you'll go down to option 9 and click enter. Now raise your hand if your calculator looks like mine. Okay, you got it easy. All right, because it's pretty much, you just fill in. Okay, we already wrote it. You just have to fill in. Raise your hand if yours just says FNINT parentheses. Okay, for you guys, it's a little bit different. All right. For that group, if yours does not show up like this, this is what you're going to actually have to do. So it popped up FININT with the parentheses, right? So, okay. You actually have to type in your function, whatever it is, and then you'll have to put in a comma. The comma is located right above the 7 button. Then you have to type in x, like the actual variable, because you gotta let the calculator know what variable you're integrating to. Then you'll put your lower bound, whatever that number is, comma, your upper bound. And then you close off a parenthesis. So anytime it pops up like this, you're going to have to go through that process. All right? So your calculator should look like FNINT 2 minus the absolute value of x.
How do you put the absolute value of x?
I'll show you in just a second. Go ahead and finish writing this out. Then you put your x. Everyone knows where x is located, right? Cool. What's my lower bound here? And my upper bound? There you go. So that's what your calculator should look like. So, everyone else, if your calculator looks like this, it's very simple. 2 minus the absolute value. You press the math button, you go over the number, and there it is, ABS. You have math and over to number ABS. And then you type in an X. Now, if yours is like mine, it actually will pop up the absolute value bars. If it's not, it'll say ABS. And then you got to close off that parenthesis. Everyone else, you just fill in the DX there. But if you have, where you actually got to put in the commas and everything, make sure you put a comma in. Put an X, put a comma, put -2, put a comma, put 2, put a comma, parentheses. And then you click enter, and it'll tell you the area, which is 4. So the area from -2 to 2 for this function is 4. All right? And also, if you look, what shape is this? And so you can always refer back to your old school geometry, geometric shapes. What's the area of a triangle? 1/2. My base is 4. My height is 2. And you get a 4.
So would it be easier to do it that way?
Well, in certain cases, if it's like that, yes, it's very much a lot easier. But you gotta make sure you remember your formulas, okay? Ones like B, though, it may look like a square, but it might actually be a little bit curved. So, you just want to be careful. If it's definitely a triangle, you can always refer back to it. If it looks like, if it's exactly a trapezoid, you can refer back to that, okay? But you do have the option to use your calculator, all right? Let's look at B. How would I write the integral for B? -1 on the bottom, 1 on the top. What goes over here? And then dx. There is my definitive integral. Now I want you guys to find the area using your calculator, okay? I'm going to give you guys a second to do that, and then we're going to see if you got it. Where are I going to get the integral? Math 9. -1 on the bottom, 1 on the top. My function is 2 divided by 1 plus x squared. Did you put it in parentheses? Because if you don't, the calculator is going to read do 2 divided by 1 and then add x squared to that result. Yes? Uh-huh. So did you guys get 3.14?
Yes, it's high. Yeah, if you put it high, it's
So yes, it is pi, so 3.14 about. There you go.
Would you put like area equals or either units or anything?
Well, actually, we would just go on the back end of this and do the equals or about 3.14. So it would be this.
So it gives it to you like that, and then write it.
Questions?
Oh, you got a comment.
If in the comments, we gotta do the,
I have a question.
yes.
Why are they different?
Honestly, I really don't know what's different. I think it might just be like, I mean, because the silver edition or anything, I mean, they're all the same, so I honestly have no idea. And really, truly, they take our calculators to this, the testing site, and so you don't know which calculator you're going to get. So you definitely need to make sure you need to know the long way. Yeah.
Yeah, you thought you were.
So,
Yeah.
No, you'll be like, I'm
Here's one property of the definitive integral. And if you notice about the other two graphs, they were like above the x-axis, right? And they actually find the area. But a function like this actually cuts through the x-axis, and then they want you to find the area in between. It's basically you gotta split it up. Okay?
So whenever it goes under the x-axis,
So it's kind of like, for this particular function, y equals negative 2x plus 4. If they wanted you to find the area, basically the shaded area here, this would be A, and then this would be B. Now you wouldn't be able to just do the integral from A to B because you have to take into account that it splits the x-axis right here at, exactly, right here at 2. So you would basically have to do the integral, the definitive integral from A to C, and then add it to whatever the area was from C to D. So if I wanted to set this up, it would have been the integral from about negative 1.5 to 2 of my function, plus the integral from 2 to 6 of my function. This is what you would have had to do to try to figure out the area of the shaded region. Okay? This would be the process you use using your calculator. Now you can very well, if you notice these are two triangles, okay? You could very well do the area of the two triangles, but the thing is, if you have any area that is below the x-axis, it is negative. So anytime there's a shaded region, part of your area that's underneath the x-axis, that area is negative, okay? So if you were to do the area of the two triangles, you wouldn't add them together, you basically do this area minus this area. Does that make sense? Yes?
So when you plug it in, like, to the normal formula, does that do it for you?
Exactly, because this part right here would give you the area that is negative, so then it kind of already compensates for it. Alright? Now, to make it up, that's about negative 0.5, so I don't know exactly if that's where that is, but we're about to do an example that applies, okay?